In this video, we will be going over the answers to the Chapter 11 Statistical Measures Self-Check online review pages from my Independent Study Guide booklet. Chapter 11, Lesson 1. Find the mean of 15, 7, 9, 25, and 4. The first step to find the mean is to find the sum of the data points. So we have to add all of these values together. When you add 15, 7, 9, 25, and 4 together, you get a sum of 60. Now you have to add the number of data points that you have. You have 1, 2, 3, 4, 5. So we have to do 60 divided by 5, which equals 12. So the mean or average of our data set is C12. Question 2. Find the mean of 3, 8, 10, 1, and 25. First, we have to add our data values to find the sum. When we add 3 plus 8 plus 10 plus 1 plus 25, we get 47. Now we count the number of data points. 1, 2, 3, 4, 5. We're going to divide 47 by 5. 47 divided by 5 does not go in evenly. 9 times 5 is 45. Subtract, we get 2 left over. Bring up the decimal point, add a 0, bring it down. 5 goes into 20 4 times, which is 20. So our answer is B, 9 4/10. Question 3. The heights in inches of 10 senior boys are 64, 65, 66, 68, 71, 72, 73, 73, 73, and 74. Find the mean of the heights. First, we're going to add all of these values together and get the sum. When we add these values together, we get 699. We are told that there are 10 senior boys, and when we count the data points, there are in fact 10, so we're going to divide by 10. We know from 5th grade that when you divide by a power of 10, you simply move the decimal point to the left the number of times of the power. There's only one 0 here, so if the decimal point would be here in a whole number, I just have to move the decimal point over one time. So 699 divided by 10 is 69 9/10. That is answer choice A. Question number 4. Find the mean for the data set 99, 103, 140, 153, 109, 92, 125, 110, 140. First, we have to find the sum of our data values. When we add these values together, we get 1,071. Next, we count the number of data points that we have. 1, 2, 3, 4, 5, 6, 7, 8, 9. So we are going to divide 1,071 by 9. 9 is able to divide 10 once, which gives you 1 left over. Bring down the 7. 9 is able to divide 17 once, which is 9. When you subtract, you get 8. Bring down the 1. 9 goes into 81 9 times. Answer choice B. Question 5. Mary Jo wants to find the average, which is another word for the mean, of her friend's weekly allowances. Use the table below and find the mean weekly allowance. We're going to add these values up. We get $45. And there are 1, 2, 3, 4, 5, 6 data points. So we will divide $45 by 6. 7 times 6 is 42, which gives us 3 left over. Bring down the 0. 6 can divide 35 times. Now we are talking about money, so we would write this as $7.50, which is answer choice C. Chapter 11, Lesson 2. Find the mode of the set of data. The mode is the most often occurring piece of data. All right, so when I look across this data, I see 31 happens twice, and I don't see any other ones repeating. So the answer is B, 31. For question number 2, it asks us to find the median for the data set. 2, 3, 5, 7, 9, 10, 12, 15. The median is the middle number. I remember this because the middle has an I and median has an I. Now, to find the middle number, you need to put all the data points in order from least to greatest. In this example, that has already been done for you. So now we need to calculate to the middle. So I always go 1, 2, 3, 4, 1, 2, 3, 4. In this case, there is no middle number, so we have to figure out what that would be. What's halfway between 7 and 9? Well, that is 8. You can do that mentally. Question number 3. The table below shows the amount that Gabriel and his friends spend on lunch on a typical day. Find the median of the set of data. Now remember, median is the middle number, and they both have I's. Okay, so in this situation, our data is not listed in order from least to greatest, so we need to do that. So these are my dollars, $1 bill values. Okay, so, and then here I have $2, and then here I have $3, and then here I have $4. So this is just helping me kind of at least start off right. All right, so I got 115, we have 115, then we have 150, then we have 210, then we have 275, then we have 325, and then we have 415 and 425. Now this is an important step. Count the number of data points you just wrote down. 1, 2, 3, 4, 5, 6, 7. And 1, 2, 3, 4, 5, 6, 7, just to make sure you included them all. Okay, now we are going to count to the center. So I'm going to go left, left, right, right, left, right, middle. So the median price was $2.75. Question number 4. Find the mean, median, and mode of $32, $37, $20, $26, $42, $39, $26, $34, respectively. Now, the best thing to do is to put these values in order first. So I'm going to put $20, and then we have two 26s, 26, 26, and then I have a 32 and a 34. Then I have a 37 and a 39. And then a 42. Count the number of data points that you have. 1, 2, 3, 4, 5, 6, 7, 8. Check. 1, 2, 3, 4, 5, 6, 7, 8. Now, I like to get the one that is the most work done with first. This is the mean, which is, see how they have an A there? This is the average. The median is the middle, M-I-D-D-L-E, and the mode is the most, okay? So these are little clues to let you know what you're looking for. So the average, I have to add these values up first. When you do that, you get a sum of 256. And again, we have 1, 2, 3, 4, 5, 6, 7, 8. So we're going to divide that by 8. 3 times 8 is 24. Get 1 left over, bring down the 6. 8 divides 16 2 times, and you do not have a remainder. All right, so the mean is 32. Mean. Now the median, we have to count to the center. So I'm going to go left, left, right, right, left, right, left, right, and then what's in the middle? Okay, so what would be in the middle of 32 and 34? Well, that would be 33. So the median equals $33. Now, the most often occurring value is 26 because it occurs twice. So the mode equals 26. Now, in our question, it lists mean, median, and mode. So we're looking for 32, 33, and 26. 32, 33, and 26, and that is answer choice B. Question 5. What is the median for a set of quiz scores? All right, now, lovely. They have everything in order here. So again, I'm going to say things to myself like, I'm going to say left, 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 right, 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 left, 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 right, 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 left, left, right, right. Okay, and it looks like 15 is my median number, which is answer choice A. Chapter 11, Lesson 3, Question 1. Find the range of the data set 145, 612, 120, 349, 515, 212, 590. So to find the range, you need to first find the maximum minus the minimum, and that will give you the range. In this case, our maximum is 612 and our minimum is 120. 2 take away 0 is 2. I have to borrow from the 6, I make that a 5, and the 1 becomes an 11. 11 take away 2 is 9, and 5 take away 1 is 4. So my range equals 492, which is answer choice D. Question 2. The price for packs of bottled water at a grocery store over a 9-week period was as follows: $3.25, $3, $3.50, $3.75, $3.25, $3, $2.50, $3, $2.75. Find the lower quartile rounded to the penny. First, we have to put these numbers in order. And in this case, the numbers in order would be $2.50, $2.75, $3, $3, $3, $3.25, $3.25 again, $3.50, and $3.75. Now, it says to find the lower quartile. And for any parents watching this video, this is what, and kids too, if you forget what they're asking for, use the words that they're talking about. The lower quartile. Quartile, quarters, dividing things into 4. So I'm going to have to divide. If I'm splitting something into quartiles, it means that I'm going to divide by 4. So we're dividing the data into 4 parts, okay? When anything's asking for quartiles, it means that first you have to divide the data into 4 equal parts. All right, well, the first thing you need to do is divide it in half. And let's count our points. 1, 2, 3, 4, 5, 6, 7, 8, 9. All right, so I'm going to go left, 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 left. And then I'm going to go right, 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 right. So my middle piece of data is right here, all right? So this will be my halfway point. Now I need to split this in half again. So this would be half, and this would be half, okay? So my data is going to look like this, okay? So this is 1/4 of the data, 1/4 of the data, 1/4 of the data, 1/4 of the data, okay? Now, when it says the lower quartile, now you do need to know something. They're talking about this piece right here, okay? Okay, so what number is that? Well, it's somewhere between $2.75 and $3. So it's halfway between. So we have to do 3 plus 2, sorry, that's not a 2. We have to do 3 plus 2.75, which equals 5.75. And we have to divide that in half. 2 goes into 5 2 times, which is 4. Okay, bring up the decimal point, bring down the 7. 2 goes into 17 8 times, which is 16. and that is 1 left over. Bring down the 5, and 2 goes into 15 7 times, which is 14, okay? And that will give us 1 left over. We're going to add a 0, bring it down. 2 goes into 10 5 times, which is 10, which gives us nothing left over. So our answer is 2.875. Now, we're talking about money, and our decimal system for money doesn't go into the thousands, so we have to round. So this would round to $2.88. And that is answer choice C. Question number 3. This is the same question as question number 2, only this time they're asking for the upper quartile. So the upper quartile would be right here. This is the lower quartile, this is the upper quartile, and this is the median. So to find the upper quartile, we're going to do 350 plus 325 which is $6.75, and we'll divide that in half. And we're going to get 3.375, and again, our decimal system only goes to the hundredths place for money. That rounds to $3.38, which is answer choice B. Question 4. Find the interquartile range of the data. So first we have to put the data in order from least to greatest. And this actually might be the most challenging because you have to put the data in order and you have to be very precise. So we have 5, and then we have 12, and then we have 15, and 23, and 42, 51, 55, 66, 68. I'm going to rewrite that. And 68. And that's 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Good. Now find the interquartile range. Again, you see this word quartile. That's telling us we need to divide our data. Oh, this pen, sorry. Divide our data into 4 parts. All right, so I'm going to go left, 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 right, 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 left, right. All right, so this is my middle number. This is my median number. Okay. And now I find the middle of the left part and the middle of the right part. Okay. And the interquartile range is from this point to that point. So what number is between 12 and 15? Well, we have 13, so we have 12, 13, 14, 15. Okay, so what's in between right here? That's 13.5. So that's the lower quartile. Oh my goodness, this pen. All right, maybe I'm pressing too hard. All right, now up here we have 55 and 66. So we could always add them together and divide by 2, but you could also just do 55, 56, 57, 58, 59, 60, 61, 62, 63, 64, 65, 66, and stop. So I can go left, 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 right, 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 left, 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 right, 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 and then what is right here? Well, that would be 60.5, okay? So now the range is going to be the difference between 60.5 and 13.5. So we're going to do 60.5 subtract 13.5. 5 take away 5 is 0. I'm going to borrow. 10 take away 3 is 7. 5 take away 1 is 6. So that's 60. Oh, my goodness. 5 take away 1 is 4. I added. So the answer is 47, which is answer choice A. Lesson 3, question 5. Find all outliers for the data. So first we're going to put the data in order from least to greatest. Our least value is 6. Then we have 8. 6, 8, 12, 14, 15, 16, 12, 14, 15, 16, 20, and 31. All right, next we're going to find the median. So left, 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 right, 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 left, right. So our median is going to be right between 14 and 15. Now we're going to find the middle of the left lower half and the middle of the upper half. We're going to make this into a box plot, kind of, sort of. All right. Now this would be quartile 1, quartile 2, quartile 3. The quartile range is going to be from quartile 1 to quartile 3. So we have to figure out what quartile 1 is. So we have 8, 9, 10, 11, 12. So it's going to be 10. And then over here we have 16, 17, 18, 19, 20. So it's going to be 18. And then we do 18 subtract 10 equals 8. So our inner quartile range equals 8. I'm going to do a little bit of erasing here to give myself some room. Now, to find outliers, you have to be really outside of your data, okay? And you have to be significantly outside of your data. In fact, you have to be 1.5 times further than the interquartile range. So what we do is we take the interquartile range and multiply that by 1.5. So we're going to do 1.5 times 8. 8 times 5 is 40. 8, 9, 10, 11, 12. Okay, and then I'm going to have 1 decimal point. So now I have to add that. This was 18. I should have written 18 here. Sorry, this is 18. Okay, and then this was 10. Now I'm going to have to add 18. I'm going to have to go 12 points ahead. So I have to do 18 plus 12, and that gives me 30. So anything past 30 is an outlier. Now I have to subtract 12, okay, going this way. Now 10 take away 12 is going to be -2. So anything past -2 is going to be an outlier. So the only outlier that we have right now is 31. Because you have to go from quartile 3 or quartile 1, and you have to go 1.5 interquartile ranges away. So that is answer choice C. Question 1. What does the mean absolute deviation of a set of data represent? A, the average of the modes of the set of data? No. The mean of the lower quartile and the upper quartile of the set of data? No. The average distance between each data value and the mean? Yes. The difference between the greatest value and the least value in the data set? No. Find the mean absolute deviation, round to the nearest tenth if necessary. Now, the mean absolute deviation, okay, and then I always say the mean again. So, the first thing we have to find out is the mean. So we are going to add all of these values together and get the sum. When I add these together, I get 55.5. Now there's 1, 2, 3, 4, 5. So I'm going to divide by 5, which gives me 11.1. So the first thing you do is find the mean, okay? Now, you're going to find the deviation from the mean. You're going to find each point's deviation from the mean. That means how far away does each point deviate from the mean, and the mean in this case is 11.1. So I'm going to take each point and I'm going to subtract it from the mean, or subtract the mean from it, okay? Okay, that equals 2 equals 1 equals 0.1. Okay, equals -0.9 equals, and that equals -2.2. Now, as you can see, I have some negative numbers, and that's where this absolute value comes in. I'm going to convert all of these to their absolute value. And if you remember from our absolute value lessons, basically the absolute value of a number is a positive value. So 2 is 2, 1 is 1, 1/10 is 1/10, negative 9/10 is 9/10, and then negative 2.2 is 2.2. Now, I always like to say the mean, absolute deviation, and the mean again, okay? Because you got to do the mean one last time, all right? So we're going to do the mean of these values. So we have to add those up. When we add that up, we get 6 2/10. We have to divide that by 5. And when you divide 6.2 by 5, I can do that up here, 6.2 divided by 5. 5 goes into 6 once, which is 5. Bring down the 2. Twice 10. At a 0, bring it down. 4. That equals 1 24/100. And it does say to round to the nearest tenth if necessary. So that'd be 1.2, which is answer choice B. Find the mean absolute deviation rounds to the nearest tenth if necessary. So now I would like to say find the mean absolute deviation, and then I add another mean here, okay? And I work backwards. So step 1, I find the mean of my data set. So I add all of these values up first. When you add all of those values up, you're going to get a sum of 84. There are 6 values, so I have to do 84 divided by 6 to find the mean. And I will get 14. All right, so I figured out the mean. Next, because I'm working backwards, I'm going to find out how much each value deviates from the mean. So I have 12, subtract 14, 14, subtract 14, 15, subtract 14, 10, subtract 14, 16, subtract 14, 17, subtract 14. It's negative 2, 0, 1, negative 4, 2, 3. Now I figured out how far each point deviates from the mean. The negative numbers are less than the mean. The positive numbers are greater than the mean. So that's why that part is important. But now I'm going to convert them to their absolute values. So it's going to be 2, 0, 1, 4, 2, 3. Because now I don't really care if the value is greater than or less than the mean. I just want to know how far away from the mean it is. And then the last part is I'm going to find the mean one more time. So I have to add up all of these values again. So 2, 3, 7, 8, 9, 10, 11, 12. And there's 1, 2, 3, 4, 5, 6. So I'm going to divide by 6. And I'm going to get 2. So what does this say? It says that on average, each plant's height deviates from the average, an average of 2 inches. Question 4, find the mean absolute deviation round to the nearest tenth if necessary. So we're going to do this again. Mean, absolute, deviation, and again, I just add the word mean again because it's a helpful reminder, and we're going to work backwards. So the first thing we have to do is find the mean of our data set. So we will find the sum of all of these values. And when you add all of those values together, you get 294. There are 6 of them, so we're going to have to divide by 6. So 294 divided by 6. 4 times 6 is 24. Gives me 5 left over. Bring down the 4. 9 times 6 is 54. I'm going to erase that. 54. Okay, so my answer is, or the mean is 49. Next, my directions are right here in the name. The next thing I do is find the deviation from the mean. So I'm going to have 35 take away 49, 48 take away 49, 51 take away 49, 45 take away 49, 56 take away 49, 59 take away 49. $35 take away 49 is negative 14. Take away 49 is negative 1. 51 take away 49 is 2. 45 take away 49 is negative 4. 56 take away 49 is 7. And 59 take away 49 is 10. So all the negative values are data points that are below the average or the mean, and the positive values are above the average or the mean. Next, I'm going to follow my directions that I'm following in my title here, mean, absolute, deviation, and I need to convert these to their absolute values. So I have 14, 1, 2, 4, 7, 10. And last but not least, I'm going to find the mean, again, of these numbers. Okay, so 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 18, 28, 38. 38 divided by 6. Okay, so we have 38 divided by 6. Another 0. That's 3, 18, 2, and this is going to be repeating. So that will round to 6.3, which is answer choice B. Find the mean absolute deviation, round to the nearest tenth if necessary. So mean absolute deviation, and we're going to just add the word mean one more time. So step 1, we're going to work backwards. We're going to find the mean. All right. Notice, just so you know, we have 1, 2, 3, 4, 5, 6, 7, 8 pieces of data now, and we have to find the sum. And when we add all of those together, we get a sum of 556. And we will divide that by 8 because there's 8 data sets. 1, 2, 3, 4, 5, 6, 7, 8. So 556 divided by 8. All right, so that's going to be 6 times 8 is 48. Bring down the 7. 4, 6, 9, 72, 4, 0, 5, 40, 0. All right, so your mean is 69.5. So we are going to have to subtract 69.5 from each data point. Whoops, getting ahead of myself here. So 56 take away 69.5 equals negative 13.5. 65 take away 69.5 is going to give you negative 4.5. 60 take away 69.5 is negative 9.5. 72 take away 69.5 is 2.5. 83 take away 69.5 is 13.5. 76 take away 69.5 is 6.5. 74 take away 69.5 is 4.5. And 70 take away 69.5 is 0.5. So we found the deviation. We found how far each point deviates from the mean. And most of our data is above the mean. Only 3 of our data points fall below the mean, and 1, 2, 3, 4, 5 points fall above the mean. So doing this helps us talk about our data a little bit more. All right, so next we're going to find the absolute value. Okay, so we're just changing all of these numbers to positive values. And last but not least, we're going to find the mean one more time. When we add up all of the data points, or all the absolute values, I should say, when we add up all of the absolute deviations, we get 55, and we have to divide that by 8, which equals 6.875. And it says to round to the nearest tenth. So I'm going to round to the tenths place, which means I look at the hundredths place, and this will become 6.9, which is answer choice C. Question number 1 for lesson 5. Refer to the set of data below. If 15 were removed from this set of data, which values would change? Okay, so first let's put the data in order. Our least value is 15. Then we have 40, 41. Then we have 56 and 59. Then we have 64, 65, 69, or 67, 69, 77, 80, 80, 81, 81, 81 again, and 82. All right, so the range is definitely going to change, okay, because with 15, the range is 82, take away 15. Without 15, the range is 82, take away 40. Because if I take 50, I'm going to actually highlight this, 15, sorry. I'm going to highlight 15. So 15 is the one that we're going to be leaving in and taking out. So if it's in, it's 82 take away 15. If it's out, it's 82 take away 40. So the range, does the range change? Yes. All right, next, let's talk about the mean. Well, the mean is going to change because if I keep 15 in there, I'm going to have a different sum, and I'm also going to be dividing by a different amount of numbers. So if I add all of these values up, I'm going to get a certain set of numbers. That's going to be different if 15 isn't there. Also, I have 1, 2, 3, 4, 1, 2, 3, 4. I'm going to be dividing by 16 if 15 is there, or I'm going to be dividing by 15. So, and because this number is like so different than the rest of the numbers, the mean is definitely going to be different. Okay. Now, let's see what else we have. The mode is the most often occurring number, and the most often occurring numbers are 81, and that would be true if 15 was in or out. So that's a no. Mean is a yes. Now the middle number, okay, let me erase this. So the middle numbers, left, 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 left. 1, 2, 3, 4, 5. Okay, so I have left, 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 right, 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 left, 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 right, right, right. The middle value is right here, okay? So I'm going to do 69 plus 60. Oh, wait, sorry, I don't need to do that actually. It's just going to be 68. So the median value is 68. Median with 15 is 68. All right, now let me erase that. and re-highlight this. Oops. 10, 8. All right, so now let's find the median without 15. 1, left, 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 right, 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 left, 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 right, 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 left, right. So the median would be 69. So the median would be, without no 15, would be 69. So that would be, yes, that's going to change. So the range changes, the mean changes, and the median changes. The mode does not change. So that is answer choice B. Which is the greatest measure of the given data? All right, so let's see here. We have, let's put these in order. 4, 4, 4. Okay, 4, 4, 4, 5, 5, 5, 5. Okay, 6, 6, 6, 6, 6, 6, 6, 6. And I see that I missed a 4 here. And then I have 7. And then I have 8, 8, 9, 8, 8, 9. And then I have 11, 13, 14. 11, 13, 14. And I'm going to count these. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. Okay, good. All right, so the mode equals 1, 2, 3, 4. There's, okay, the mode is 4 and 6. Central tendency is not really like a calculatable thing. It's just like a discussion about overall. So the median is, we're going to calculate the median here. Left, 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 left. Right, 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 right. Left, left, left. Right, right, right. Left, right. The median is 6. Now we're going to find the mean. So I have to add up all the data. So when we add all of these up, we get 120 divided by 17 equals 7.058, and the numbers keep going. So that is 7.058. So the answer is A. The mean is greater, is the greater measure. Number 3, which measure of central tendency is most representative of the data? All right, so we have, okay, we have 2, 2, 2, 3, 4, 5, 5, 6, 6, 28, oops, sorry, no, 8, 8, 28, and 32. All right, so the range is 32, take away 2, which equals 30. The mode is 2, because that is the one that happens the most frequently. The median is left, 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 right, 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 left, left, right, right. What's between 5 and 5? 5. So the median is 5. All right, and we are going to add up the data for the mean. All right, so when we add up all of the data here, I'm going to use a different color. We get 103. There are 12 data points, so I'm going to divide this by 12 using a calculator, and I get 8.583, and the 3 is repeating. Now that point would be right here. So this is where the mean is, and this is where the median is. And the question is which measure of central tendency is the most representative of the data? Now in this case it would be the median, because 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 pieces of the data are actually closer to the median than the mean, okay? Because these values are affecting the mean much greater than the median. These 28 and 32 are outliers. So when you have outliers, most often the median is the better representation of the data. Which measure of central tendency is the most representative of the data? Okay, so we're going to put these in order. Okay, we have 1, 1, 2, 3, 3. 1, 1, 2, 3, 3. 4. Okay, and then we have 17, 18, 19, 20. Okay, now the range is really never like the best representation of the data, really, unless you're asking like a specific question that has to do with that. And I don't know, unless again the question is very specific to the mode, that's usually not the best one either. So we're going to eliminate those. All right, so the middle number, left, 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 right, 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 left, right, and this is the median. All right, and that is 3.5. Now we are going to find the mean. When I add up all of the data, I get 88. There are 10 pieces of data, so I can divide by 10, and that gives me 8.8. So the mean is right here. Now, I personally think that the mean is your better piece of data, because you really do, this data is, you have a lot of low scores and a bunch of high scores. So I believe that the mean is your better data. You don't really have any outliers because 1 is just as far away from the mean as 20 is. And your data, is pretty symmetrical otherwise. There's a huge gap in the middle. Question 5. Which measures of central tendency are representative of the data? All right, so let's put this data in order. We have 5, 8, 10, 13, 13. $15, 18, 20, and 152. Okay, so here's the deal. You're not going to have, the median is not going to give you the best picture of the data because you have to include 152. So that's going to skew the median really far away. Okay. So really, we're talking about, really the median is going to be a better one. Now, when I look here, they're not just giving me the choice of just the median. Okay. So I see median here, and median here. All right. So I know the mean is not going to be good. All right. So that's really just going to leave me with the mode. So let's figure out what the median is. Left, 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 right, 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 left, right. I had a feeling it was going to be 13 because the median is 13, and guess what the mode is? The mode is also 13. So because they match, the median and the mode are the best answers for this. Okay. Now you could figure out what the mean is by adding up all of these values and then dividing. But I think by doing all these exercises, you can realize that 152 is really going to skew your mean. Okay. And there you have it. All right. So here's the vocab portion. The blank is the numbers or items that appear most often in a data set. Well, that is the mode. Numbers that are used to describe the center of a set of data are measures of center. The difference between the greatest number and the least number in a set of data is the range. The blank of a list of values is the value appearing at the center of a sorted version of the list. That is the median. Now, center is another word for middle. And notice I have an I here and an I here. The blank is the distance between the first and third quartiles of a data set, and that's interquartile range. A value that is much higher or much lower than the other values of a data set is an outlier. All right, good luck.